Would you like to leverage the maximum amount of benefits from your structural analytical model? Would you like to get detailing and production drawings with minimum effort? Well, let's find out how. Let's see how STAAD Advanced Concrete Design can improve your current workflow and help you produce designs quickly and easily. STAAD Advanced Concrete Design enhances the design of the standard structural elements. It has the capability to design in detail elements like beams, columns, slabs, foundations, pile caps, slabs, shear walls, and staircases. You can use STAAD Advanced Concrete Design to design, analyze, and detail irregular shapes like L, T, and C shapes quickly. Every company has their own design requirements and standards. With STAAD Advanced Concrete Design, you can specify the preferred detailing settings and rebar settings to be used for your projects. STAAD Advanced Concrete Design allows the users to create and manage engineering drawings with a click or two. You can produce comprehensive reinforcing drawings including automated rebar labels, dimensions, and notes, as well as rebar placing drawings including sections, plans, and details from your 3D model. It's easy to get the bill of material or cost of design. You can gain critical insight into concrete design alternatives with comprehensive material takeoffs and cost estimation, organized by material, size, and shape. STAAD Advanced Concrete Design is built for engineers around the world. Extend the reach of your business practice and take advantage of global design opportunities by using a wide range of international standards and specifications. Choose STAAD Advanced Concrete Design to improve your workflow in designing and detailing concrete structures.
CIV 533 Analysis and Design of Bridges using STAAD version 8. So the list of experiments or the list of practicals are as follows. This is a vast and a complicated topic, so we have to start with the introduction and we have to deal with the prerequisites required for the successful completion of the course. We'll start with the options available in Visual Studio 19, hydraulic design of bridge structures we will deal. Then concepts about the trench bedding and foundation design, and some little introduction to Python coding and syntax. And for bridge design, we know that we deal with the moving loads. We'll also give a small brief introduction or insight to the various types of vehicle and classification of loads, and what is the effective span width for a bridge deck slab. And we will use Picket method. Indian standard code is based on Picket method, so we'll give brief introduction to that also. This is a very nicely designed course that is having a lot of relevance in industry as well, and students should look forward to master this. Analysis of slab using moving load in the STAAD. Then we have parts of the bridges, that is pier column, then design of T-bridge or box culvert, then eventually we'll go for the design of steel truss bridges. So whenever we start a course or a program, we should always refer to its outcomes. What are the intended outcomes? That at the end of this course, or the behavioral outcome that student should able to demonstrate or exhibit. So at the end of the course, be able to determine the various loading parameters as per IRC provision to analyze a bridge structure. Then analyze the complexity of numerical with basic coding and syntax with the software skills. Develop the worksheet interface for using Visual Studio and Excel as per the user need for the design field. Outcome 4 is compute the structural design and detailing from the result output and optimize the structure. And the various references are mentioned as per the scheme and syllabus are the design of bridges by N. Krishna Raju, essentials of bridge engineering by Johnson and Victor, design of bridge structures by Jagdish and Jayaram, IRC 6 2017, IS 783, that is the code for practice for laying concrete pipes. Then IRC SP 16 is designed for culverts and small bridges as per IRC, and IRC 112, that is code of practice for concrete road bridges for Indian Road Congress. So these are the references. We will share with you the excerpts of interview from a senior Bentley or STAAD.Pro scientist or a designer, the interaction will excite you to learn more about the new features, and it will excite you to be a good learner in this course.
STAAD is a brand of products that is essentially there to provide a set of solutions for structural analysis and design. The main product that we deliver within this brand is STAAD.Pro, which is the primary generic analysis and design tool that is used throughout the world in a wide variety of different installations and environments. And consequently, we've developed the program in a number of different areas to leverage the ability to do analysis and design in those specific markets, but in a simpler and more constructed method. We've done this by pulling together design codes and providing them completely within the program. In the past, where we've tried to make the program operate regionally slightly differently, we've recognized that that's not necessarily provided the best experience for the majority of users. So we've simplified the program and included all of the international design codes that were separated into different licenses into the main product. We've also recognized how significantly engineering itself has changed within the way that projects are now being developed and delivered on site, and the way that BIM workflows are now becoming a primary method by which projects are being worked on, and ensuring that data can be effectively managed through the process by using a system that utilizes physical modeling is really at the heart of that. We've also seen how advanced analysis is becoming more and more a prerequisite rather than a nicety. So rather than having this as an attachment, we're now delivering the main program with this as a clear capability, either a standard solution or the advanced solution. We obviously want to continue providing additional codes and interoperability for different environments and different situations, and we'll touch on how some of these capabilities have been introduced into the program. We also really want to make this an easy operation to move from a different environment. So if you've been using a different piece of software or an earlier incarnation of STAAD, we want to make this a simple process for you and an easy operation. So we want to be able to provide you lots of great information in terms of learning and tools for which you can explore the different capabilities that you need for your daily work, that we really want people to leverage through using the Connect Edition. And the fact is, we are dealing more and more with an interoperable solution. We recognize and have spent a lot of time developing and continuing to develop solutions that allow your digital data to be more than just a STAAD.Pro solution, but also part of this wider context of your disciplines. So we've implemented and developed a standard for which the digital data can be transferred around the engineering environment, and they're not just limited to Bentley's own solutions, but also solutions that are developed by third parties or independent standards such as CIS and IFC. That we've simplified how STAAD.Pro is being delivered as a single offering which contains the standard solver, this ability to do physical modeling, and all our design codes. This means that we now don't have to worry about whether models we're working with might introduce QTLs by mistake because they've included design codes for design code packs that weren't perhaps included within your organization's portfolio. So we simplified it, put them all in, and made that a great offering for you. As I said, we've now got a solution which goes beyond that though, and our advanced solver gives you this with the STAAD.Pro Advanced. All of that great capability from within STAAD.Pro, but also with this vast performance boost by utilizing the advanced analysis solver. So that gives us our two primary solutions. But then there's a third offering that I really want to draw your attention to, which is a structural enterprise. It's actually just a minimum extra in terms of cost of offering, but with that you get all of the STAAD.Pro, STAAD.Pro Advanced, but also all of the other products that are within the STAAD brand and also within the RAM brand. So you get different methods for defining your structures using a RAM structural system or slab design with RAM concepts, and absolutely fantastic tools that are fundamental to so many construction projects. And also this is all delivered as a single structural enterprise at very little extra over the standard costs. So I mentioned how much better the Connect edition is over the standard version, the VAI version. In actual fact, the ability to utilize Connect will mean that you are able to run about 50% faster, 1.5 times faster than your old VAI solution. And that's if you just go from VAI to Connect. And I think you should do more than that. The reason I say that is if you can go from your standard to advanced, you're going to get not just 1.5 times, but 25 times faster on average. Clearly, it depends on the type of model and the solutions that you're working around, but 25 times can make a significant difference in terms of sitting around. If you don't want to just be waiting there for your analysis to solve, then the advanced solver is going to give you that capability. In actual fact, we did a study on this to try and work out what happened. This is also not just a case of doing designs using these most powerful computers that are available on the cloud, but also the fact that you're able to now take your structure without having to take your model or your desktop to site and start making utilize the benefits of having the data available. And on site, you can use this to define any RFIs that may be found due to issues that are discovered on site, simply by utilizing some of the cloud services and our mobile platforms. So there is a lot of fabulous new work that is going on within the program, and as well as what we're delivering within the program today. So I think this is really a huge step forward in terms of how structural analysis and design is being performed today, and I believe that this is a major step forward that all engineers should be looking to utilize as soon as possible. So to do this, we've actually introduced a radically new UI. When I say radically new, it's actually the behavior that you get within the program actually follows the processes that we've been developing and implementing over the previous generations of the program. The main look and feel of the program may slightly change, but that change is to become more in line with the behavior that you've become accustomed to when you're working with your other office environment, your other office products, so Word, Excel, for example. But also the tools that we have provided, we didn't want to push those completely to one side, because we've recognized that these are great ways that models can be created in a simple and graphical way that makes a lot of sense to structural engineering. So these tools that we've developed in the past are still available, but we just put them into a user interface that follows the logic and the facilities that you would expect to find in programs like Excel and Word. The reason we're showing this here as well is that we've come across a lot of our engineers who operate on this program. They tend to still think in terms of creating their data using the spreadsheet methods of adding data directly into tables or using the editor. Now these are great tools, and we're clearly making use of those. But what we're showing here is that you have a lot of great tools that help actually modify the structure in terms of the way engineer to actually think and approach problem solving. So modifying the model simply by identifying the bits of the model that you want to work on and making those changes makes it a lot easier than having to remember individual node numbers or member numbers and working in that context. Here, for example, is one of the capabilities that we've had available, and a lot of you, I'm sure, will recognize this from the VAI versions, in being able to generate the finite element plate models, where you might want to include the ability to define the structural support for a foundation or a slab or a wall. Now, these are all finite elements, and those finite elements are entirely applicable for structural analysis and design. But one of the things that we recognize so much these days is the fact that these finite elements are thinking in terms of the analysis solution. And what we want to do is think more as a structural engineer and less as the analytical operator. And that's what we're going to be looking at and coming on in a later part of the presentation. So one of the big changes that are taking place. But at this point in time, I just really wanted to highlight and illustrate here how you still got, for those who recognize the current program, how we still utilize the capabilities from within VAI, but we're now presenting it to users in a methodology. So I've mentioned this workflow, this user interface that we've spent a lot of time working with engineers, are important users and people who have used STAAD in over the years. Structural analysis itself hasn't changed. In actual fact, what I wanted to identify, or what I wanted to illustrate here, is the fact that we do provide these analysis methods of far more than simple elastic analysis. We've got the capabilities of doing a dynamic analysis or a response spectrum extraction and solution for seismic type events. But if you, and I'm sure you often find now, more and more your requirements are to go beyond the basics of a standard first order elastic analysis, or even the basics of a P delta, accounting for those effects that take place during the analysis on more slender models. You need to start looking at the effect of the geometric modifications that take place during the analysis, and have those remodify the stiffness matrix and get a more accurate simulation as to the structural situation that occurs during a structure as it approaches a buckling criteria. So as we look at these situations, we want to be able to do that, and we can provide that with the STAAD.Pro Advanced solution. The main concern that we always have when we start developing a new generation of the program is the fact that a lot of the engineers who use STAAD.Pro today and have been using it for its for the years that it's been delivering these solutions, is that the editor has been seen to be a fundamental part of how an engineer can understand and represent their model, almost as in the sense as a timeline, and use this to generate the stages through which a structure will be considered. The editor has always been a nice tool which we've provided in order to enter the data. With the VAI Select Series 6 version, we provided the first generation of the IntelliSense capabilities. The other thing that we have provided, and more engineers are starting to make use of this now, is the idea of using code snippets. In other words, being able to define standard data blocks in a way that can be entered and modified easily. And also the fact that the data itself can be linked to the standard databases means that as you work with the editor and you put the data in, you actually put it in a way that correlates with the analysis that you're going to be performing, rather than just a simple editor for a simple text editor like Notepad, where you end up having to spend ages trying to work out what the naming convention might be. What I mean by that is that we now have within the Connect edition not just an analytical method of creating your structural models and working with those, but also with physical models. As I said, these are very much now the heart of a BIM workflow, where you're transferring data, where you want to be able to certainly transfer the data as efficiently as possible to other stages through your design process. So that may be through modeling or through detailing or fabrication, where the same model of the same fundamental model you need to have as part of that. So we have a completely newly designed application or module within the program, our physical modeling environment, that allows you to create these physical models simply by following a process very similar to that has been well established for analytical modeling, but this time maintaining the concept of the physical objects, and so those objects in themselves can be managed and handled simply through the workflow. So a member that is actually part of a physical detailing environment can be passed through. And this is entirely managed through the physical environment, but that physical environment then can be used to generate the same STAAD format, STAAD file format, or the STD file that you may have recognized as the files that you've used from day one of the program. So here we're just simply creating a relatively straightforward example of a model, but as you can see, very simple process. All of the data is created, but all based on those physical entities, and those physical entities, including the surface, are defined as a single object, and those single objects are then managed so much easier when you want to work in your BIM workflow. So we've essentially